Let us look at the method of partial fractions to find the sum of a sequence, or rather evaluate the series. So we are given S sub n is equal to 1 by 1 times 2 plus 1 by 2 times 3 plus 1 by 3 times 4 plus dot dot. Now here, the first step is to figure out what is happening in the terms. So this might have been given as 1 by 2. But looking at this pattern, we should know that there has to be a product here. So we write it as 1 by 1 times 2. Now, what would be the nth term? Numerators are all 1. In the denominator, you have 1 times 2, 2 times 3, 3 times 4. So if we treat this as n, then this will be n plus 1. So our nth term would be t sub n is equal to 1 by n times n plus 1. This we split it into partial fractions. There is a separate course on partial fractions in my channel, so you can go through that. Here, let's apply that. So let 1 by n times n plus 1 equal to a by n plus b by n plus 1. Now we have to figure out what a and b are. So let's combine these two terms. We get a times n plus 1 plus b times n by n times n plus 1. The denominators both cancel out. So we are left with 1 is equal to a times n plus 1 plus b times n. Regrouping this, we get a plus b times n plus a. Now we equate the coefficients. So when we equate the coefficients, you notice a is a constant, and on the left hand side there is a constant 1. So that means a is equal to 1. On the right hand side we have a plus b times n, but there is no n here. So that means it is 0. So we have a plus b is equal to 0, which implies a plus b equal to 0, which implies b is equal to minus a. And since we already have a equal to 1, so b becomes minus 1. Now substituting this a and b values into this expression, we get 1 by n times n plus 1 is equal to 1 by n minus 1 by n plus 1. Now, this is pretty simple example. In the next example, we will look at a much more complicated one. S sub n will be 1 by 1. 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 2 plus 1, 3. Next term, 1 by 3 minus 1 by 3 plus 1, that is 1 by 4. And so on up to 1 by n minus 1 by n plus 1. Now here you notice minus half plus half, minus 1/3 plus 1/3. So this is a telescopic sum where most of the terms will get cancelled out except some of the boundary terms. So all the terms except first and last terms cancels out. And we have S sub n is equal to 1 minus 1 by n plus 1. Combining them, we get n plus 1 minus 1 by n plus 1, which is n by n plus 1. So this is the formula for finding the sum of n terms in this series. So let's verify with S sub 1. So S sub 1 is equal to 1 by 1 plus 1. That is 1 by 2. Now what about the sum of first two terms? S sub 2 is equal to 2 by 2 plus 1. That is 2 by 3. We manually do it, we get 1 by 2. And here what happens is S sub 2 is equal to 1 by 2 plus 1 by 6, which is equal to 3 plus 1 by 6, which is 4 by 6, which is 2 by 3. So they both check out. So that was finding the sum of n terms in this series using the method of partial fraction. Now let's look at another example. We have S sub n is equal to 3 by 1 square times 2 square plus 5 by 2 square times 3 square plus 7 by 3 square times 4 square and so on. What will be the nth term? In the numerator, we have odd numbers starting from 3. In the denominator, we have n square times n plus 1 square. So our nth term is t sub n is equal to 2n plus 1 divided by n square times n plus 1 square. We split the fraction into partial fractions. We have 2n plus 1 by n square times n plus 1 square is equal to a by n square plus b by n plus 1 square plus c by n plus d by n plus 1. Combining these terms, we get a times n plus 1 square plus b times n square plus cn times n plus 1 square plus dn times n plus 1 divided by n square times n plus 1 square. The denominators cancel out and we have only the numerator on both sides. Now, simplifying it, we get 2n plus 1 is equal to a times n square plus 2n plus 1 plus bn square plus cn times n square plus 2n plus 1 plus dn square plus dn. Further simplifying, we get an square plus 2an plus a plus bn square plus cn cube plus 2cn square plus cn plus dn square plus dn. Keeping the like terms, we have cn cube plus a plus b plus 2c plus d times n square plus for n we have 2a plus c plus d times n plus a. Now we equate the coefficients. Now coefficients of n cube, if we look at it, we have c as the coefficient of n cube in the right hand side. On the left hand side, we don't have n cube. That means it is 0. So straightforward, c is 0. That means the third term in this has disappeared. Coefficients of n square is this. So we have a plus b plus 2c plus d. Now n square is also not there on the left hand side. So that is equal to 0. Now since c is 0, 2c is 0, that means a plus b plus d equal to 0. Now coefficients of n, we have 2a plus c plus d equal to 2. C is 0, that means 2a plus d equal to 2. And constant term a is equal to 1. So we have 2a plus d equal to 2, which implies a is 1. So 2 plus d equal to 2, which implies d is equal to 0. That means the fourth term also has disappeared. A plus b plus d equal to 0, which implies 1 plus b plus 0 is equal to 0, which implies b is equal to minus 1. So we have a equal to 1, b equal to minus 1, c equal to 0, d equal to 0. So our nth term becomes 2n plus 1 by n square times n plus 1 square is equal to 1 by n square minus 1 by n plus 1 square. These two will become 0. So now that we have got the partial fractions of which is the nth term, let's do the summing. Now s sub n is equal to 1 by 1 square minus 1 by 2 square plus 1 by 2 square minus 1 by 3 square plus 1 by 3 square minus 1 by 4 square and so on up to the nth term. That is 1 by n square minus 1 by n plus 1 square. Again, it's a telescopic sum. Minus 1 by 2 square plus 1 by 2 square minus 1 by 3 square plus 1 by 3 square. So up to 1 by n square, it will cancel out. And we are left with the first term and the last term. That is 1 minus 1 by n plus 1 square. Simplifying that, we get s sub n is equal to n plus 1 square minus 1 by n plus 1 square. Opening up the bracket, we get n square plus 2n plus 1 minus 1 by n plus 1 square. simplifying that, we get n square plus 2n by n plus 1 square. Factoring the numerator, we get s sub n is equal to n times n plus 2 by n plus 1 squared. So this is the formula for finding the sum of first n terms in this series. As usual, let's do a verification. S sub 1 is equal to 1 times 1 plus 2 by 1 plus 1 square, which gives us 3 by 4. 3 by 1 square times 2 square, which is equal to 3 by 4. Similarly, for S sub 2 is equal to 2 times 2 plus 2 by 2 plus 1 square, which is equal to 8 by 9. So S sub 2 is equal to, now, manually doing it, 3 by 1 square times 2 square plus 5 by 2 square times 3 square gives us 3 by 4 plus 5 by 36, which is 27 plus 5 by 36, and it simplifies to 8 by 9. That means this is also verified for first two terms. So that was the method of partial fractions for evaluating a series up to n terms. Now, if you found this session useful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you next time. Bye for now.